how to find the specific heat from the specific heat equation and finding how much heat is either given off or taken in using the Q equation for specific heat, we're going to take that one more step into finding delta H. Remember, delta H is something we call enthalpy, right? Enthalpy. That means it's the change in energy for a given amount of substance. Okay, so this is going to be done very much similar to that of the finding Q. Okay, but we take a couple more extra steps. So it says when 12.8 gram sample of potassium chloride dissolves in 75 gram of water in a calorimeter, the temperature drops from 31 degrees Celsius to 21.6 degrees Celsius. Calculate the delta H for the process. So the first thing I'm going to do is I'm going to find how much heat is given off or absorbed in this equation. So to do that, I'm going to find the heat equation, which is Q is equal to MC delta T. Now here I don't know what Q is, but I do know what M is. M is 75 grams of water, because that's the surrounding. So this is 75 grams of water. All right. C is specific heat of water, which is 4.184 grams per joules per gram Celsius. And the change in temperature would be the final, which is 21.6 degrees, subtract the initial, which is 31.0 degrees Celsius. All right. So all I'm going to do is I'm going to multiply all this together. So I'm going to take out my calculator, and I'm going to go 75 multiplied by 4.184 multiplied by parentheses 21.6 subtract 31 close parentheses equal, notice I have a minus 2949.72. all right, so that is my amount of heat given off. So the amount of heat given off again was 2,949.72 joules in this case. Guys, notice that all the units factor out. Okay, so grams cancels here, Celsius cancels here. Okay, so now all I have is joules. Now remember, this is going to be negative, right? Because this number becomes negative. So this is negative. So this is Q of the surrounding, which is the water. So in step 2, what we have to do is now that Q of the surrounding is equal to negative Q of the system. Remember, the system is what we're focusing on. So Q of the surrounding we know is negative 2,949.72 joules, which is equal to negative Q of the system, which is a negative 2,949.72 joules. So that's positive, right? So this is equal to the Q of the system, all right, which is positive, which is equal to positive 2,949.72 joules. So now all we have to do is the third step is we have to take this gram of potassium chloride and convert it to moles of potassium chloride, right? So we have 12.8 grams of potassium chloride. Multiply that by, I know that 1 mole of potassium chloride is 1 mole potassium, which is 39.10. Okay, so potassium is 39.10. Chloride is 35.45. So that's a 5, 5, 4, and 6, 74.55. So 74.55 grams. Okay, so then that means I have to take that divided by that, and when I get that, I get basically 0.172 moles of potassium chloride. Now to find the delta H, all I have to do is take the Q of the system, which is 2,949.72 joules in this case, right? Divide this by the moles, which is 0.172 moles, and when I do that, I get 1,701.79.81 joules per mole. Or I can actually change this to 3 decimal place 1, 2, 3, 17.18 kilojoules per mole. So let's go over all the steps that you need to do this. Okay, so to find delta H, we basically have 3 steps. So to find delta H, or to find enthalpy, first step, we have to calculate basically, calculate the Q of the surrounding. Okay, now the Q of the surrounding is usually the water. Okay, once we have the Q of the surrounding, we're going to go step 2, which is to calculate the Q of the system. Okay, now remember, I just go back here to find this Q of surrounding is equal to mc delta T. Now remember, m is the mass of the surrounding substance, which is usually water. C is of course of the surrounding substance, and delta T is of course the temperature change. So calculate the Q of the system. All we have to do is take the Q of the surrounding and we go negative. So this is negative Q of the surrounding, the opposite, right? So if the system picks up heat, then the surrounding must be given off heat. And if the system is given off heat, then the surrounding must absorb heat. Then the third step, what we're going to do is we're going to take the amount of the system, we're going to calculate the moles of the system. Mole of system. Okay, whatever the system is, we're going to calculate how many moles of that system we have. And on step 4, what we're going to do is we're going to take the moles of the system and we're going to divide that by the Q of the system, okay, and that will give us delta H, or the enthalpy per mole. Again, if you have any question, make sure you ask in class.